Hello everyone, welcome back. This video is just going to be focusing on factoring because in the next unit, chapter 6, we're covering rational functions, and for rational functions it'll be very helpful to factor the numerators or denominators, and more on that later. But so let's get into the factoring. So I'll do the answers in red. So the first method, so this is all of these methods. Each of these methods, the GCF method, the difference of squares, the AC method, the sum of cubes, and down here the difference of cubes. All of these methods have been covered in earlier videos in a factoring series, and there's actually a factoring playlist you can reference. So I'll make sure to put that card in this video so you could just click on that and follow that to the factoring playlist if any of this isn't clear, because basically it provided that this is all clear, then you won't really need to review factoring. But if this isn't clear, then please go back and check out those factoring videos. So alright guys, let's get into it. I'm going to cover these a little bit quick, so let's get into it. I want factoring to be natural for you all. So we begin with this. We look at the GCF method for this problem. We have x cubed, x squared, and x. So the GCF, the greatest common factor of x cubed, x squared, and x is just x. And then factoring out an x from x cubed leaves us with x squared plus x plus 1. That's fully factored, so that's the first question. Next, we have a difference of squares. So remember that more generally, a squared minus b squared is a plus b times a minus b. In this instance, a is 5x and b is 9. Therefore, this just factorizes as a plus b times a minus b, a plus b times a minus b, and remember a is 5x, so it's 5x plus 9 and 5x minus 9. So we fully factored that problem with the difference of squares method. Next, let's tackle the AC method. This one's a little bit more lengthy. So the first thing that we need to do is we need to multiply a and c together. So this is a, this is c, and then the negative 5 is b. So a here is 21, b here is negative 5, and c here is negative 4. Now the AC method, basically, it's not cleverly named, it just means multiply a and c together. So we get 21 times negative 4, and that leaves us with negative 84. Is that right? Double check me, but I think that's right. And now what we want to do is we want to consider what are the factors of 84 that would give us a sum of negative 5. So what I'm going to do is I'm just going to take the factor tree of negative, or I'm going to essentially determine all of the factors of negative 84. So first we could have negative 1 times 84, or negative 84 times 1, but we can see neither of those would sum to negative 5, so we just keep on going. Negative 2 times 42, and then negative 42 times 2, but again that's too high. Next, we see if 3 goes into it. Yes, 3 goes into it, I believe, 28 times. So we have negative 3 times 28, and we have negative 28 times 3. We keep on going along. We have 4 times 21, so negative 4 times 21 and negative 21 times 4. We're still not to a sum of negative 5 yet, though. We got to keep going, just keep on chugging away. The next thing would be 6, so negative 6 times 14 and negative 14 times 6. I think we're almost there. And then there's negative 7 times 12, and negative 12 times 7. Phew! I believe that's all of the factors of negative 84. Double check me there, but this should be all of the factor pairs of negative 84. And now we're looking for the factor pair which would add up to negative 5. So that means we take this factor pair right here, because negative 12 plus 7 is negative 5. So we take that factor pair, and here's what we do. We basically take what we had originally. We had 21x squared, so I rewrite that part. But now, what we do is we break this minus 5x into two pieces. We break it up into minus 12x and a plus 7x. So that minus 5x got split up into these two pieces here, negative 12x and 7x. And now what we want to do is apply the greatest common factor method to each of these pairs, each of these groupings here. Well, there's no greatest common factor on this side, but we'll note that later. And then for this one, we have a greatest common factor of 3x. So it's 3x times 7x minus 4 plus, what do you know? 7x minus 4. So now we can factor out a 7x minus 4, leaving us with 7x minus 4 times 3x plus 1. And to cover that a little bit more slowly, 7x minus 4 is here and here. So we factor that out. We factor that out of the first term, and what's left over is just 3x. We factor that out of the second term, and what's left over is just plus 1, because this is really like 1 times this, so there's really like a 1 right here. So that's why we get 3x plus 1 as the other factor. Each of these contributed to this factor here. So now this is fully factored via the AC method. It's 7x minus 4 times 3x plus 1. AC method's probably the most involved, and I actually realized I chose a slightly difficult example computationally, so usually, like for a test or something, it might not be this hard. So let's move on to the next example. We have a sum of cubes. Now the sum of cubes formula and the difference of cubes formulas are given in previous videos. They're a little bit longer, so I'll write them here, but yeah, I'll write the sum of cubes formula here. I won't go into how to memorize it in this, but there is a video on how to memorize this, by the way, that I've made. Plus b squared. Okay, a plus b times a squared minus ab plus b squared. That's the sum of cubes formula. So all we need to do is determine what a is and determine what b is, plug it all into that formula, and simplify. So here a would have to be 2x, because if I take 2x and I cube it, I get 8x cubed. And b would be 3, because 3 cubed gives you 27. Alright, so a is 2x, b is 3. Let's take those, plug them into this formula. So just kind of carrying down an equal sign from up here, we have a plus b, so that's 2x plus 3, times a squared. Well, a squared is 2x squared. So I'll just write that for now, 2x squared, minus a times b, so minus 2x times 3, plus b squared, plus 3 squared. And now what I'm going to do is I'm just going to simplify this. So this is the same thing as 2x plus 3 times 4x squared minus 6x plus 9. Now this is fully factored via the sum of cubes formula. Lastly, in this small amount of space, I'm telling you we can do it in this very small amount of space, we have a difference of cubes. So we need to determine what a and b are. So really the difference between these two formulas, so like the difference of cubes formula, is this. It's really similar to the sum of cubes formula. The a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So essentially the first two signs of it got switched around. So notice it was plus here, now it's minus. It was minus here, now it's plus. But enough on that, let's get into the problem. So a here is what? Well, what's the cube root of this term? What do we cube to give us this? Well, a would have to be xy, and b would have to be 5. Awesome. So now let's take that, let's plug it in. So we'll plug this into that formula. We would have a minus b, so that's xy minus 5 times a squared, so that's xy squared. I'm going to actually just simplify it here. It gives you x squared y squared. And then plus a times b, so that's plus 5xy plus b squared, so that's plus 25. All right, so we factored 5 different problems with the 5 main factoring methods that you need to know. So if you have any questions about these, please ask me in class or via an email. It's really important that factoring is down solid before moving on to rational functions. So I hope you guys like this video. I hope it was helpful for those of you that may have forgotten some things about factoring. So I guess we'll see you in the next video on rational functions. Have a great one, guys.